Hey, welcome back. Okay, so tomorrow during class we're going to be doing another lab. This lab we're going to be creating motion diagrams. We're going to be testing how fast cars go. Okay, obviously we're going to be in a lab environment, so we're not talking about full-size life cars, but we are going to be talking about little toy cars. So we're going to be playing with toys again. Okay, so we're going to be creating motion diagrams. What the whole thing is how do the motion diagrams of a fast toy car and a slow toy car differ? So we're going to take two of these cars, and we first have to find out which is the fast one and which is the slow one. So we're going to visually test that, and then we're going to be creating the lab. So we're going to be studying this by doing the lab that's on page 48 through 49 in your textbook. So as you watch the video, you might want to get your textbook out and follow along. Okay, so the procedure that we're going to be doing is we're testing two cars visually to see which one's the fastest. So both of these cars are wind-up cars, so they're the kind of cars that you want to push backward and then you let go. So make sure that they're fully wound up, and we're going to test them. We're going to do both of them together and find out visually which one's faster. And the way that we do that is which one, you can see which one is moving faster. So you're going to start with the slower car first. Okay, so we're going to place a meter stick parallel to the motion of the car. So if the car is going this way on your lab table, you're going to put some meter stick right alongside the motion of the car. You're going to place the slower car at the starting line, and then you're going to record the motion of the car with a video. So you're going to record the video as the car is moving along that parallel to the meter stick. The meter stick is going to help us determine the distance that it's traveling. We're going to replay that video frame by frame, reading where the position is at each frame. The frames are going to reference the time that it takes to get through each of those. So as long as you keep that time consistent from frame to frame, then you can find the distance that it's traveled in that time distance. So we're going to record that data for every 0.1 seconds around. We're not going to be specific on the 0.1 seconds in the data table that's going to be part of the lab. We're going to repeat this steps 3 through 6 for the faster car as well. So we're going to do this 2 times, one for the slow car, and then we're going to do it again for the fast car. Oops, got a little problem with the boards here. Okay, then what we're going to do is we're going to do the same thing only with the slow car, but we're going to create a ramp. So we're going to take a piece of a track and we're going to move it up 30 degrees. And we're going to be able to do this using a compass or a protractor. We're going to create this ramp. We're going to place the meter stick on the ramp once again along the pathway of the car. We're going to place the slower car on the ramp. We're going to wind up the car and we're going to let it go. At the same time, we're going to video record the car in motion down the ramp. And you're going to repeat steps 5 through 6 from the previous slide and record that data, the motion that it's moved down the ramp. Please pause this video now and go back into your textbook on page 48 and read the procedure that they have written and make sure that you understand. If there's any questions, come first thing in the morning and make sure that your questions are answered about what you're going to be doing on the video. Okay, so what do you have to do for homework with this video? The first thing is I want you to come prepared with a lab written up already for all the information ahead of time. Okay, this doesn't have to be formal, it can be handwritten, but make sure that you write your objective. And this can come from the textbook. The materials that you're needing, once again, it can come right from the textbook on page 48 and 49. And then you're going to write your procedure. Now I want to make sure that your procedure comes from the textbook as well as from what I've spoken about today in the video. It does not have to be word for word. It really shouldn't, but it should go into detail about what you're doing. Do not say step 1, race 2 cars, or record the video. Make sure that you've put all the steps in your procedure. And then the last part is just rewrite the data tables that are in your textbook. They have them put out in a really nice order. Rewrite those and make sure that they're large enough so that tomorrow when you come in, you can enter the data into those tables. Okay, and then the last thing, we're going to be using an app from the iPhone, which is called Video Physics. It's a free app. If you would like to download it, that's fine. If you do not want to, you do not have to. Someone in your group will have it, and I will have it on the class iPad. Okay, so if you have that, you're going to download the Video Physics, that's the name of it, Video Physics, from the App Store. And once again, it is a free download. If not, and you just want to use your regular recorder from your phone, that's fine as well. Someone in the group will be able to record that. If not, I will have some available in the classroom. So that's all you have to do. Make sure that you have these things written in a nice order, and so that you can come ready to do the lab tomorrow. Thank you, and we'll see you tomorrow. We'll have fun racing cars.